Hello everyone. So, we will continue with the moisture measurement, moisture in textile topic. So, we are now discussing the moisture and fiber properties. In last class we discussed that the absorption of moisture by a textile material, it results swelling in diameter and also that in turn result the shrinkage of textile material. And now, as far as mechanical properties are concerned, the most cotton is an example where the with the moisture regain, the strength of the fiber increases, but in rest most of the fiber, the mechanical properties, the strength reduces with increase in moisture regain, content of moisture inside the fiber, and electrical property, electrical resistance reduces with the increase in moisture content in presence of moisture in fiber, because water is good conductor of electricity, whereas textile material, most of the polymeric material are not so good conductor of electricity. And also the static electricity generation, this problem it's more when the air is dry. In dry condition, the textile material, the content of moisture in textile material is low, that is why it generates static electricity, and that creates lots of problem during processing or even during use. So, we must have seen that the textile material, particularly synthetic material, it sometimes stick to our body, that even layers of cloths stick. So, this is actually due to the static electricity generation. So, another important effect is that it is a thermal effect, and that directly affect the comfort sensation of during wearing cloth. So, absorption of moisture, it actually it releases heat, it's called heat of absorption. Now, that it is a very common example. Suppose in winter, in cold countries, in winter the room become hot and humid, hot and dry. So, dry at low temperature, at a low humidity, from a person from a hot room with a low humidity, when he is going out in cold condition. So, in that case what will happen? Suppose this is a room which is hot and relative humidity percent is low, relative humidity. Now, when someone is going out in cold environment and with high humidity, suppose it is snowing at high, very cold outside. In that case, when he is going out, the textile material will absorb moisture, textile material will absorb moisture and release heat of absorption. Heat of absorption he will release, that will keep the person who is wearing the cloth, keep the person warm. So, that heat generation, heat will get generated, the heat of absorption will get generated and balancing of heat, otherwise body would suffer sudden cold shock, he will suffer. So, that is actually that buffering action is done by the textile material. And another property is that is called the warm cool touch, which is actually expressed in terms of Q max. that means the transient heat actually it takes away from our body. So, it increases with the increase in moisture present. So, moisture present in the material if it increases. So, if the Qmax value increases with the increase in moisture content, which means that the fabric feels cooler at higher moisture content. So, for all the fabrics, all the different types of fibers, the Qmax value increases. So, higher Qmax value means the fabric actually feels cooler. So, it is also clear that the linen fabric has maximum Qmax value. So, it is maximum Qmax value, that means the linen fabric is cooler in touch. Okay. So, this means that, and wool has got its a least Qmax value. So, for any moisture or any relative humidity, if we touch linen fabric, it will be cool in touch and wool will be warm. So, another effect is that is a effect of time, as we have discussed due to the moisture hysteresis characteristics. A sample takes a certain amount of time to reach the equilibrium. This rate of conditioning depends on the size and form of material and the type of material. Like cotton, let us take an example of cotton and polyester. So, polyester material will reach equilibrium quickly, because the cotton absorbs moisture and forms certain bond, okay, because of the presence of cellulosic material. So, that means its release, its drying behavior, it is very slow. Okay. That is why depending on the type of material and also the shape of material, like if we talk about the yarn in loose hang form or fiber in loose form, those will absorb or dissolve moisture, exchange moisture quickly than the fiber in bale form or yarn in package form. So, form of material also affect the moisture exchange capability, and as the relative humidity increases, the regain increases, that we have already seen. So, this is the hysteresis curve. Depending on the time, the moisture value changes. Another effect is the temperature, although there is no direct impact of temperature, at least for lower temperature. Lower temperature it has, but definitely at higher temperature the fabrics, the textile material will get affected, there will be damage. But as far as moisture is concerned, if we increase the temperature to some extent, the moisture content will increase, although there is no direct impact, because at high temperature the atmosphere can hold more and more moisture. So, that will allow the textile material to absorb higher moisture content, moisture from the atmosphere, because the moisture availability at high temperature is more. Another factor is that the previous history of the sample, that moisture regain or moisture content will change if the material, the cotton is bleached or scoured. So, raw cotton if we keep, it will absorb certain quantity of moisture, like say 8.5% if we keep it in the normal standard atmosphere, but because it has got some wax material, some other impurities. Okay. But if we bleach the cotton or if we scour it, then the amount of moisture, the moisture regain or moisture content will change because of this removal of this wax material. Okay. So, the moisture changes with the previous history of the material. Now, coming to one of the most important part, which is correct invoice weight. So, the buyer pays for material, not for moisture or water. Okay. Suppose we are supplying a material with higher moisture content, why should buyer pay for the water, excess water? And also at the same time, it is not possible to sell material without any water, because it is a nature of the textile material. So, that means there must be some standard acceptable moisture regain, okay, that the standard regain is available, and accordingly it is also not possible that, suppose what I am trying to sell, it is not it's the moisture content in that material is different from the standard, okay, that is okay, but I have to make some correction. I have to bring the total weight of the consignment as per the standard moisture allowable, and if I do that, that means I am correcting the invoice weight, and that the total trade will be based on the correct invoice weight. Now, so correct invoice weight has to be determined. Now, let us see how to calculate. When consignment is to be delivered and weighed, a sample is taken. So, first before delivery we must take a sample from the consignment, and then we have to test for actual moisture present in that material, that test sample, and that sample we have to take as per the sampling procedure that we have seen, we have discussed earlier, and as per that we have to make sample, and we take the sample and measure the actual moisture content in that material, in the sample. Okay. And say total weight of consignment is W, capital W is the total weight of consignment. At that point the sample is taken from the consignment, a small mass is taken, that is consignment is a large total consignment, and small sample S mass is taken. Okay. The sample is then oven dried, and the weight is D. D is the dry weight of the sample S. That means, S minus D is the actual water content. Then we have to calculate the oven dry weight D, okay, of the consignment, and this D, that sample is dried, so D, and from that we can calculate the oven dry weight of the total consignment, W multiplied by D small d divided by sample weight. So, this is the D is the oven dry weight of the consignment, and from there we can calculate the correct invoice weight. D is the oven dry weight, calculated oven dry weight, and R is the allowable official regain of the material. So, D multiplied by 100 plus R divided by 100, this is the correct invoice weight of the consignment. Now, the total trading will be based on this correct invoice weight. Okay. Now, these are the standard values of regain for some of the materials. There are lists of the materials, are the official regains are available. So, we have to correct accordingly. Now, let us do some numerical. Here the problem is that 20,000 kilometer of 150 denier yarn at 8.5% moisture content is shipped. So, 8.5% moisture content we have actually we are shipping, we are actually selling. Now, what should be the correct invoice weight if the moisture content, moisture regain of that material is 6%. We do not know the material, but here moisture regain, official moisture regain is given, it is 6%. So, and what we are selling is it is at 8.5% moisture content we are selling it. So, that accordingly we have to calculate the correct invoice weight. So, first thing is we have to calculate the total mass of the material 20,000 kilometer of 1.5 denier filament. Okay. So, length of the yarn is 20,000 kilometer, denier is 150 denier and moisture content is 8.5% and official moisture regain is given 6%. So, this all this data are given. Now, let us calculate the moisture correct invoice weight. Now, mass of 20,000 kilometer of yarn, okay, of 8.5% moisture content. So, the mass at 8.5% moisture content is 333.33 kg, which is coming from 150 denier and it is a 20,000 kilometer and we are dividing by 9 because 9,000 meter and we are converting it to meter and 9,009. So, that it is becoming 9. So, it is coming out to be 333.33 kg, that is the actual mass of the consignment we are shipping, okay, at 8.5% moisture content. Now, next thing is that we have to calculate the dry weight, and this is the equation for moisture content, that is the weight of water and total weight by 100. So, this is the total weight means W plus D is 333.33 kg and mass of water we can calculate. So, 85% means 0.85 multiplied by 333.33, it is a 28.33 kg is the mass of water. So, dry mass will be oven dry weight will be 333.33 minus 28.33, it is 305 kg. So, the dry mass of the material, this 20,000 kilometer material, it is a 305 kg. So, that is the dry. Now, we cannot sell, we cannot actually raise invoice on 305 kg because the 6% moisture content is allowed anyway. So, then we have to again add 6% moisture content, moisture regain we have to add. So, they what is happening? So, correct invoice weight becomes the dry weight. So, official regain is 6%. So, dry weight multiplied by 100 plus 6, 106 by 100. So, 323 kg. So, our total invoicing will be on the basis of 323 kg, not on 333 kg. So, this is the correct invoice weight. Now, let us try to see how to calculate the correct invoice weight of the blended material. So, this is 50,000 kilometer of 40 NE 80-20 polyester cotton yarn. So, we have polyester cotton blended yarn at 4% moisture content is shipped. So, we know the moisture content of the, what will be the correct invoice weight, and official moisture regain of polyester and cotton are given as 0.4% and 8.5% respectively. The problem is exactly same as earlier problem, only difference is that here it is a blended material. So, length of material is known and cotton count. So, we are converting it to direct count, because it is nothing but it will be simpler. So, 14 ticks, 40 NE means 14.76 ticks and moisture content is given, official moisture regain of blended yarn. So, that we have to calculate, and we have to we will calculate using earlier equation. So, this is the earlier equation. So, 0.4 okay, the moisture content and 0.880%, okay, and then 8.5% and 0.2. So, 8.5% is the percent regain, okay, percent regain of polyester, 0.4%, percent regain of cotton 8.5%, 80% and 20%, then it is coming out to be 2.2% of this is the moisture regain of the blended material, and then moisture content is 4%, and we will now calculate the total weight mass of the material will be 738.125 kg, and this mass is having with its with 4% moisture content. Then we will calculate the oven dry weight. So, this is the W plus D is 738 kg, and the mass of water present is this. Okay. This is the mass of water present 29.525 kg, and we will get the oven dry weight, it is 708.6. So, 738.125 minus 29.525. So, 708.6 kg is the oven dry mass, and then we can calculate the correct invoice weight. So, this is the dry mass 738, and official regain we have already calculated 2.02%, and correct invoice weight is 708.6 multiplied by 102.02, because 2.02%. So, 2.02 by 100. So, 722.9 kg is the correct invoice weight. So, we will actually will not raise invoice on 738 kg, but we will raise invoice on 722 kg, 22.9 kg. Okay. Now, we will discuss another important characteristics of any textile material. It is basically in the fabric form, that is a air permeability. What is air permeability? It is basically its measure of the flow of air. So, how well a fabric allows to pass the air through it, and it is extremely important not only for apparel. For apparel it is important because of comfort. Okay. So, if it allows, whether it is allowing air to pass through or not, accordingly we can actually come to know that whether it will allow moisture vapor permeability or not. But in technical textiles, in especially for filter, tent, shell cloth, parachute cloth, the air permeability is extremely important, because in filter, if the air permeability is less, then it will not allow the air to flow through. That means, the filtration performance will be very poor. So, it will create high pressure drop. Similarly, for tent or shell cloth, if its air permeability is very high, then it will be a problem. If it is totally blocked, that will be problem. So, there should be some controlled air permeability. Similarly, for parachute cloth, okay, there must be some air permeability, so that it controls the rate of descent. Okay. The air permeability, it is the volume of air which pass through 1 second through 1 centimeter square under a pressure of 1 centimeter of water head. So, it is the actually rate of air flow through fabric per unit area per unit pressure. That is the definition of air permeability. The measurement principle is exactly same as that we have used in air flow method of the micron air value. The cotton fiber micron air value, that is the linear density measurement. The similar method is used here, that is the in this here it is a air pump is there, air suction is there, and in that the fabric is placed here, specimen is placed here, and air, it will suck air, air will flow and it will measure the flow rate. Okay. The flow by liter or cubic centimeter per second, like that it is gauged, and the rate of suction is adjusted. So, that the unit pressure difference is there. Okay. So, that is the air flow rate, that is the measurement technique, and air permeability changes with different parameter. Like if the cloth cover factor increases, if the cloth becomes compact, air permeability will reduce and this will help us in designing the cloth for parachute cloth, parachute fabric, for filter fabric, for many application. We must know the relationship between cloth cover factor and air permeability. Typically this relationship, it is a logarithmic relationship. So, if we take the logarithmic value of air permeability versus the cloth cover factor, then the curve will be straight line. Okay. This is the almost straight line curve. So, that it varies with the logarithmic value of air permeability. Another factor is that if we change, here we can see, if we change the twist factor of yarn. So, this plot is the against in x axis the twist factor of weft yarn versus air permeability. So, keeping all other parameters constant, if we change the twist factor, that means the diameter of weft yarn is reduced. So, effective cover factor is increased, cover factor is reduced, diameter as diameter is reduced. So, a fabric cover is reduced. So, it will allow more and more air to pass through. Next is that shape factor of filament. Okay. As the filament shape factor increases, keeping all other parameters constant, suppose we have prepared a different fabric made of polyester filament of different shape. Okay. If we change so this is the say circular polyester, this one is a certain shape, another is this one is with different shape. So, its shape factor increases. As the shape factor increases, keeping ends per inch, peaks per inch, diameter of the linear density of fiber, everything constant, it has been observed that the air permeability of fabric reduces linearly. This is because of that the higher shape factor will present more surface area and it will actually restrict the air flow rate. And we will stop here. We have finished the air permeability. Thank you.